Another inferential meter is the liquid turbine meter. Now, the liquid turbine meter is an inferential device which measures flow rate in the meter tube. It functions by sensing velocity of fluid passing through a known cross-section of the meter tube.
As the fluid passes through the meter housing, it causes the rotor to spin. The speed of the rotor is directly proportional to the velocity of the fluid. Because this velocity is determined by the volume of fluid, rotor speed can be used to calculate volume flow. Turbine meter construction is relatively simple. The meter itself is installed directly in the meter tube. The meter is a precisely balanced, free-running rotor mounted in a cylindrical housing, similar to a flanged pipe. This unit is mounted on the pipe's center line. A magnetic pickup assembly is positioned as close to the rotor as possible but does not penetrate the housing. As liquid passes through the meter, it causes the rotor to rotate. The rotor blades pass through the magnetic field of the pickup and generate a pulse in the pickup coil assembly. Each pulse represents a distinct unit of volume. Added over time, the total pulses represent the total volume metered. The turbine rotor is mounted on a shaft by an up and downstream hanger assembly. Although these hangers might resemble straightening vanes, they do not perform this function. The turbine rotor blades are set at a predetermined angle. This angle relates the flowing stream, angular velocity of the rotor, and the frequency of the meter. The rotor rotates on the center line shaft by means of a bearing. This bearing is either lubricated by the meter fluid itself or permanently sealed. However, to minimize the load on the bearing, the rotor also floats. Now, this floating occurs as liquid entering the meter is deflected outward by an upstream cone, which increases its velocity and causes a slight pressure drop. After passing the turbine blades, the flow is redistributed. Because the rotor hub is larger than the upstream cone, some of the fluid flows directly over the hub. The rotor then floats in balance between the upstream cone and the downstream cone. The magnetic pickup assembly is mounted on the exterior of the meter housing and counts the rotor blades as they pass. The blade tips of the rotor are made from or contain magnetic material. This material creates pulses in the pickup coil as the blades pass. These counts, or pulses, represent a unit of volume.
So far we've talked about inferential meters. Let's look now at a volumetric measurement device, the positive displacement meter.
This meter continuously divides the flowing stream into known volume segments. The segments are isolated momentarily, counted, and then returned to the stream.